Till our last session, last class, we have learned about the definition of Boolean algebra. Today, we shall illustrate that definition through an example, considering an example. Here, I have considered a non-empty set, capital X, and it's a power set, P of X. What is power set? I do think you all know. That is the set of all subsets of the set X. Set of all subsets of the set X, and the collection of those subsets is called the power set of X. And here we have considered two distinct members from this power set, P of X. That is, AB are two subsets of the set X. And as the binary operation, we have defined here union and intersection. That means in place of addition, we have considered union. In place of multiplication, we have considered intersection. That means if we recapitulate the definition of Boolean algebra when we have defined it in our previous class, we have written a Boolean algebra by either by this 6th tuple or this 4th tuple. And here was B is the non-empty set, plus is the binary operation, dot each multiplication is another binary operation, and complementation is the unary operation. In place of this plus addition and multiplication dot, we are using the notation union and intersection respectively. That means in place of addition, we are using the union of two sets, and in place of multiplication, we are considering the intersection of two sets. And complementation is the usual complementation of a set. That means a complement means this set difference the whole universal set. Here the universal set is X as we have considered, and therefore the A complement will be X difference A. Okay. And we are telling that P of X, this non-empty set P of X, the power set of X, that means the set of all collection of all subsets of X, will be a Boolean algebra with respect to these two binary operations, union and intersection, and the unary operation, complementation. And here the null set phi will be the additive identity element, and the universal set or the considered set X will be the multiplicative identity element. So let us now see how it is possible. Here we have considered three arbitrary members from P of X. That means three non-empty subsets of X. Three non-empty subsets of X. We all know this union binary operation is commutative. So A union B obviously will be equal to B union A. The change of the component will not affect. And A intersection B equal to B intersection A, as you all know from the set theory. And we also know the distributive property for set theory, and merely we are using that very distributive property here. That means A union B intersection E, B intersection C is usually equal to A union B intersection A union C, and A intersection B equal to A intersection B union C equal to A intersection B union A intersection C. These are the distributive properties from set theory. We already know that. And in case of phi, the null set, if we union this null set with any other set, the same set will be returned by the property of this null set. So A union phi equal to A for each and every member of A of P of X. And if we consider the universal set, whole set X, and A being a subset of this set X, A intersection X equal to A. So we can say that phi is the additive identity, because in place of addition we are considering this union operation, and X is the multiplicative identity, because in place of multiplication we are considering this intersection. And the fourth one was for the Huntington's postulates, the fourth property was in case of addition, that means here A plus A complement will be the multiplicative identity. Here we have obtained the multiplicative identity as capital X. So if we union this A union A complement, obviously this will be equal to the whole set X, because from the definition of the complement what we have done, A complement equal to X difference A. So the set of the elements which are not, the collection of all elements from the set X which are not in A. Here I have shown this by this example. If X be the collection of these four natural numbers 1, 2, 3 and 4, and if A be the set 1, 2, then A complement will be X difference A. That means the collection of all elements which are not in A, this is equal to the remaining elements 3 and 4. Okay. So if we union these two sets, that means A union A complement, the whole universal set will be returned. And as these A and A complement are two distinct members, distinct or disjoint members, that means A complement is the elements which are not in A but in the universal set. So the intersection of the common portion of this set will be phi. This is the equal to the additive identity. So in case of this addition operation, we are getting the multiplicative identity, and in case of this multiplication operation, we are getting the additive identity. So all the four postulates due to Huntington's are satisfied here. And since ABC are three arbitrary members considered from this power set P of X of X, P of X will form a Boolean algebra with respect to these two binary operations, union and intersection, and the one unary operation, this complementation of set. So this is a Boolean algebra, P of X, comma union, comma intersection, comma complementation, comma phi, comma X, as I have written here. Clear? And here phi plays the role of 0 element, that means the additive identity element, and X plays the role of the multiplicative identity element 1. Okay, thank you everybody. In our next class we shall continue from here. Thank you.